It says sketch a qualitative reaction energy diagram for a chemical reaction with and without a catalyst. Assume the uncatalyzed reaction is endothermic. So we're going to do two reaction coordinate diagrams again, just like in the previous question on this playlist. And we're going to have energy in kilojoules per mole, and we're going to have reaction coordinate, or progress, if you will, of the reaction, and it's going to be the same for both sketches. And we just need to have the two axes set up. Now, this is going to be the uncatalyzed reaction, and this is going to be after we add the catalyst, so the catalyzed reaction. So a catalyst is something that speeds up the chemical reaction and is not consumed during the reaction. So in this case, we don't have the A, B's, and the C's that we had in the other one, so I'm just going to put this as the reactants. And over here, I'm going to put the same reactants. And then I need to also identify the products, or product, we don't know, but the reaction is endothermic. So since the reaction is endothermic, as I explained in a previous video on this playlist, the product or products will be higher in energy than the reactants. So these should be at the same level. The reactants are at the same level, the products are at the same level. And now we need to look at what happens when we catalyze the reaction. So a catalyst makes a reaction go faster. Reactions go faster if they have a lower activation energy. And generally, a catalyzed reaction goes through a different mechanism, which will produce intermediates that are at will sometimes produce intermediates and or transition states that are at lower energies. And sometimes even a catalyst goes through more steps. A catalyzed reaction goes through more steps than an uncatalyzed reaction, but we're not going to get into that here. So for the uncatalyzed reaction to go slower, we need a relatively high activation energy. And then for the catalyzed reaction, which goes faster, we need a relatively low activation energy. So the catalyst lowers the activation energy and therefore increases the rate of the reaction. The uncatalyzed reaction has a much higher activation energy and therefore it goes slower. If you haven't viewed the previous video on the playlist, I go into more detail about how we find the relative place to put the reactants and the products, and how we view the activation energy in terms of the rate of the reaction in a little bit more detail. But here, in case you've already watched that video, I just wanted to get right to the point.